How are you, dear?
I'm great. How are you?
I'm wonderful. This is yours. Have fun.
Thank you. Good afternoon. My name is Mehaa Amirthalingam, and my mentor is Dr. Hansen. Water scarcity is a fast-growing issue across the world. As you can see the dark colored section of this map, nearly half of the world faces water-related issues every day. Unless we make minor adjustments in the way we utilize water, we may have to make huge compromises in the future. Here is a simple illustration of how gray water can be reused and collected in toilets. Water from sinks and showers can be filtered, stored, and reused in toilets. Other examples of gray water includes water from washing machines and dishwashers. In this project, I have developed a new toilet flushing system called Aria that has several additional parts compared to the traditional toilet flushing system. I drilled a second opening in the toilet tank to install a gray water fill valve similar to the freshwater fill valve. In addition, Aria has a small tank around the freshwater float, as well as a drain valve and a float. This float opens and closes this drain valve. I do not have a gray water storage system in my house, but there are many commercial products available in the market for collecting and storing gray water. To focus on the development of a new toilet flushing system, I simulated the gray water by using the fresh water from a faucet in my bathroom. My hypothesis is that if the gray water flow can be used to stop the fresh water, then the freshwater savings will be very high. Here is an animation of how my system works for testing my hypothesis. As soon as the gray water fills a small tank, the fresh water stops, and the gray water overflows from the small tank into the main tank, and eventually stops the gray water by the action of the gray water float on the gray water fill valve. If the gray water is unavailable, then my system will work with the fresh water alone. In this case, the fresh water will fill the main tank first, and then it will overflow into the small tank to stop the fresh water. After I verified my hypothesis in a qualitative manner using my first prototype of Aria, I simulated and developed theoretical models to study my system in a quantitative basis. My theoretical models includes 3 equations. 1 for the material balance of the water in the small tank, 2 for the material balance of the water in the main tank, and 3 Bernoulli's equation relating the water level in the small tank and the draining flow rate. I was mainly interested in the change of the water level as a function of time in the small tank for optimizing my final product. What you're going to see is a video recording of a toilet flush using Aria. Pay close attention to the black tube marked as freshwater. As you can see, the gray water rushes into the small tank, but there is no fresh water coming out of the freshwater tube. By lifting the float when flushing, the drain valve closes, which results in 100% fresh water savings. This was one of the biggest accidental discoveries in my entire project. My initial prototype was a big failure because I underestimated the power of water, as there were many leaks in the system as I tested it even before I installed it in the toilet. Although I had 2 other successful prototypes, I call my most efficient prototype Aria. My initial prototypes were not designed for maintenance and were only created for testing my hypothesis. But in Aria, I took the advice from a panel of water experts from 3M, and based on their suggestions, I developed my product, and they also suggested me to use commonly available and used toilet materials and plumbing materials to use in my product. Now Aria can be completely dismantled to replace any part if needed. The 3M materials that I used in my products were the 3M marine glue, the 3M silicone sealant, and the 3M metal weld, as well as a 3M squeeze bottle that Dr. Hansen had sent me. This plot was created to find the minimum gray water flow required for 100% freshwater savings. The gray water flow rate that keeps the minimum point above 1.5 inches is the minimum gray water flow rate. This 1.5 inches is half the height of the small tank. I tested all my prototypes for the minimum gray water flow required, and here are the results. The minimum gray water flow required for Aria is 2.1 gallons per minute, which can be easily acquired and achieved from an overhead tank. In the near future, I plan on requesting fundings and contacting water conservation agencies and requesting fundings and meeting up with toilet system manufacturers for a mass production of my product. I also plan on meeting up with, collaborating with 3M to create and package Aria with a new filter and systems manufactured by 3M to offer a turnkey solution for recycling water. I would like to thank everyone, especially 3M and Discovery Education and Dr. Hansen for their invaluable support and guidance. Thank you.
So I hope I'm not stealing anyone's question here, but can you talk to us a little bit about the name Aria and why you came up with that? Thanks, that was a good question.
In India, actually the first mathematician and first astronomer in India was Aryabhatta, which was actually my inspiration, as this product is the first of its kind, so that's why I named it Aria. No problem.
So how much additional plumbing would be required to get the gray water from wherever it's being stored into your water tank? And coupled with that, so you use the freshwater source to pump water in, and that was just tap water coming in?
Yes.
So you use that to simulate the gray water. What would you imagine it would take to plumb a house so that the gray water would hook back up to your toilet?
There are already gray water storage systems available in the market. So there are many apartment buildings and commercial buildings using gray water, mainly not in the United States, but in places like India. There are apartment buildings that already have gray water storage systems and model homes and stuff like that. But to install a gray water storage tank, you will need a pump, a tube, and a gray water storage tank, maybe in your attic or wherever you want to place it. So that would be the main plumbing required. But for my system, you would only need an additional hole in the toilet tank. No problem.
This was such a cool presentation. I really enjoyed listening to you. Do you know if there could be any other potential applications for a system like this?
Can you rephrase that question?
The whole idea and system you created, could you use that for any other potential places or other applications? So you're using it for a toilet right now, but is there anything else it can be used for?
My system was specifically made for a toilet, as there's a gray water valve and a freshwater valve. And people are already second thinking using gray water in toilets. And I don't think selling out or using products or gray water storage systems in other places like showers would be really useful, and people would really want to do that. Or in sinks, like you're washing your hands, you're not putting more stuff into your hands to make it dirty, right? So mine is specifically for toilets because nearly 25% of domestic household use is used in toilets, and that's a waste of water, as people in Cape Town can only ever imagine for having that kind of water. So that's why I focused on using gray water in toilets.
Thank you very much. It was
Thank
wonderful.
you.
I really enjoyed listening to your presentation. I'm wondering about keeping the toilet clean. So if you're going to do a mixture of fresh water and gray water, and the gray water's, for example, coming from the shower, that's going to have all the soap scum and stuff from the shower. So what do you imagine doing to make sure that I don't have to clean my toilet all the time?
I plan on creating or adding filters before it goes into the gray water storage tank, because this product is very sensitive to huge particulates and soaps. So it would be really great if the water is filtered, as gray water is filtered water from showers, sinks, and washing machines and dishwashers. No problem.
You're probably going to guess I'm going to make you go back to the equations. I'm the math guy. So I'm trying to understand what you showed there. Let's see, where was it? Keep going back, I think. There you go. So talk me through what you're showing, dH dt, F minus Q over A. What is all that?
dH by dt is the change in height versus the change in time. And that equals F1, which is the gray water flow rate, minus Q, which is the draining rate. And divided by A is the area of the small tank. And for the main tank, dH by dt is a change in the water level over the change of the function of time. And F2 is the freshwater flow rate plus the draining flow rate, because the freshwater and the draining water is coming into the same place. And it's divided by the area of the main tank.
Thanks.
Problem.
You've mentioned that there are some reservations about currently available gray water reusage. How would you convince someone that your product, Aria, is healthy and safe?
I believe that using Aria in like a practical way, like flushing toilets, like how many times do you flush a toilet per day? And in commercial buildings like this, if it's implemented, then you will save 25% of water in your household, like the amount of water you use per month. So in places like California, the amount that you have to pay for gray water and for water is $200, and 25% of that is $50. So in a year, in 4 years, you'll get your return of investment as gray water storage tanks, and this system will be like $2,000 for the gray water storage system, but my system is $30. So you get your return of investment, and you'll also save a lot of water. Thank you.
Thank you. You did a great job.
Thank you.
I love the questions too about the names, right? I like that's really clever. Just a suggestion for future innovations, like Lance would be a good name. Nice job. Another round of
Thank
applause.
you.
So for those of you that are watching, everybody here, that concludes our 2018 Discovery Education 3M Young Scientist Challenge finalist presentations. Let's have you all stand. One more round of applause for our finalists. All right. Thank you for joining us. Have a wonderful day. Bye.